Okay, so today we're going to be talking about the fundamental trig identities, and we're going to be using these trig identities to simplify expressions. Okay, first things first, we have the reciprocal identities. So that's just saying that sine is equivalent to 1 over cosecant, tangent is equivalent to 1 over cotangent, and secant is equivalent to 1 over cosine. Okay, and vice versa. Cosine is equivalent to 1 over secant, cosecant is equal to 1 over sine, and cotangent is equivalent to 1 over tangent. Okay. We also have the Pythagorean identities and the tangent and cotangent identities. Right. We'll notice that not only is tangent equivalent to 1 over cotangent, but tangent is also equivalent to sine over cosine. Okay. And cotangent is equivalent to cosine over sine, as well as over here we saw that it was equivalent to 1 over tangent. Okay. All right, so let's get to the Pythagorean identities. We have sine squared plus cosine squared equals 1. We have 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. Okay, just some notation that I want to point out to you guys. Let's use tangent as an example. So what does tangent squared theta mean? Okay, this is really equivalent to tangent theta squared, okay? But it's not equal to tangent theta squared if you write it like that, okay? This is not equivalent to these two forms. Okay, so when we see tangent squared theta, we should be associating that with the quantity tangent theta, quantity squared, okay? Not this one. All right, so first things first, it says on the unit circle, x squared plus y squared equals 1. And we discussed how this x comma y on the unit circle we associated with cosine theta comma sine theta. Okay. What I want you to keep in mind too is the Pythagorean theorem. I'll call it Pythag theorem. So what the Pythagorean theorem says is if we have a squared plus b squared, that's equivalent to c squared. Or in other words, if we take two legs of a triangle, two legs of a right triangle that is, and square them and then sum them together, that should be equivalent to the hypotenuse squared. Okay. In this case, the legs of our triangle would be x and y. And that would be equivalent to our hypotenuse squared, which our hypotenuse of a unit circle is just 1. So that would be equivalent to 1 squared. So this is where we get the fact that x squared plus y squared equals 1. All right. Now let's replace x and y with cosine and sine. So I'm going to replace x with cosine, and I'm going to replace y with sine. Okay. So rather than writing x squared plus y squared equals 1, I'll write cosine of theta squared plus, and then I'll replace y with sine theta squared, and that just equals 1. Okay, so that's where we get our first Pythagorean identity. Cosine squared theta plus sine squared theta equals 1. Okay, so here's our first Pythagorean identity. Now we're going to use that to derive the other two. So let's just start out with that cosine squared theta plus sine squared theta equals 1. Okay. What I'm going to start with is just dividing everything by that cosine squared theta. Okay, so cosine squared theta divided by cosine squared theta, that's just going to be 1. Anything divided by itself is 1 plus. Now we have to keep in mind that this is the sine squared theta divided by cosine squared theta. We can really rewrite that as sine theta over cosine theta quantity squared, right? And that equals 1 over cosine theta quantity squared. Now, what is sine over cosine? If we look back here, we can see that sine over cosine is really our tangent. Okay, so I'm going to replace sine over cosine with tangent. So this will become tangent theta, and that quantity will still be squared. 1 over cosine, what's that equivalent to? Well, 1 over cosine, if we look at our reciprocal identity, we can see that secant is equivalent to 1 over cosine. So we'll replace that with secant. Okay. So now if I rewrite this, I'll have 1 plus tangent squared theta equals secant squared theta. Okay, and that's going to be our second Pythagorean identity. And for our third one, again, we're going to start with cosine squared theta plus sine squared theta equals 1. Okay. But now rather than dividing everything by cosine, we'll start by dividing everything by sine squared theta. Okay. We can rewrite cosine squared theta over divided by sine squared theta. Rewrite that where we just have that cosine theta over sine theta inside the parentheses, and we're going to square that quantity. Plus, this just becomes 1, and then we would have 1 over sine theta, and that whole quantity squared. Cosine over sine, if we go back here, cosine over sine, we can see that that's equivalent to cotangent. So let's replace that with cotangent. So I have cotangent theta squared plus 1 equals 1 over sine. Well, 1 over sine would be the cosecant. Okay, so I have cosecant theta squared. And finally, I can rewrite this as cotangent squared theta plus 1 equals cosecant squared theta. And that is our last Pythagorean identity. Okay. So let's go ahead and use those identities now to help us simplify the expressions. Okay. Whenever I simplify expressions, I oftentimes will convert everything to sine and cosine to see if we have any terms that cancel out or divide out. And then once I simplify as much as possible, I'll go ahead and rewrite it using simplest terms. Okay. So, for example, the first one, I like to get everything in terms of sine and cosine first. So cotangent, remember cotangent, if we write that in terms of sine and cosine, is really cosine x over sine x. So that's what I'm going to rewrite it as. Cosine x divided by sine x. Okay. And since we're multiplying, I can divide those signs, right? Sine of x divided by sine of x is 1, and I'm just left with cosine x. Okay. For number 2 over here, keep in mind that when we square that binomial, we have to FOIL, multiply first, outer, inner, last. So first times first, that's going to give me sine squared x. Both the outers, that'll give you negative sine x cosine x. Both the inners, again, another negative sine x cosine x. And then both the last, we have plus cosine squared x. Okay. I'm going to regroup these. I do see a sine squared and a cosine squared, and I know that I have that Pythagorean identity that sine squared plus cosine squared is 1. So I'm going to try to place these together. Sine squared x plus cosine squared x. And then I'm going to combine these like terms. So if I combine those, then I have minus 2 sine x cosine x. Okay. And like I said, this right here was a Pythagorean identity, right? If we look back, here it is right here, sine squared theta plus cosine squared theta equals 1. So if I have sine squared theta plus cosine squared theta or sine squared x plus cosine squared x, I can just replace that with 1. So here I'm just going to replace that with 1. And then I have my minus 2 sine x cosine x. And so this right here is going to be my answer. 1 minus 2 sine x cosine x. Okay, and I can't rewrite that as anything else. Sine x times cosine x, I can't rename that as any other identity, using any other identity. Okay, so if I go on to number 3, again, I like to write it in terms of sine and cosine first. So this will be cosine x times. Now remember secant, if I want to write this in terms of sine or cosine, this is equivalent to 1 over cosine x. Then I have times sine x. I can see that these cosines will divide out, right? It just is equivalent to 1. So really I'm just left with 1 times sine x. So sine x is my answer. Okay. For number 4, again, we always want to try to write this in terms of sine and cosine if possible. But before I even do that, I notice 1 plus cotangent squared x. I notice that that is just simply a Pythagorean identity. If I go back here, 1 plus cotangent squared x, I can see that that's just equivalent to cosecant squared x, or in that case, cosecant squared theta. So I'm going to replace that numerator with cosecant squared x. And in the denominator, we'll have the sine squared x. Now I'm in a position where there's not really anything to cancel yet. So let me go ahead and rewrite this in terms of sine or cosine. I know that cosecant, here I'll write it up here. I know that cosecant is equivalent to 1 over sine x, right? Cosecant x is equivalent to 1 over sine x. So before I can get it in that form, I see that I have cosecant squared x. Keep in mind that I can rewrite this as 1 over sine squared x divided by sine squared x. Okay. Now the reason why I was able to rewrite the numerator this way is because just like cosecant x is equivalent to 1 over sine x, if I look at doing cosecant squared x, that's equivalent to 1 over sine squared x, and so on. Cosecant cubed x would be equivalent to 1 over sine cubed x, and so on. Okay? Because remember, all we're doing essentially here is this can be written like cosecant x quantity squared, okay? Which really that would just be 1 over sine x quantity squared. And here if we square 1, it's just 1. And if we square the bottom, sine, that is how we're getting that sine squared x. Okay? So we know that we can rewrite it that way. Now it's a matter of simplifying. So I'm going to copy the top, change the division right here to multiplication. and multiply by the reciprocal of the denominator. So I'm going to multiply by 1 over sine squared x. So what do we get? That would be 1 over sine to the 4th x. Okay. And now I can't cancel anything else out with it written the way it is. So now I can rewrite it as its simplest form, which would be cosecant to the 4th x. Okay. Again, we want to convert everything to sine and cosine, try to cancel out as much as we can, and then when we get it down to a form like this, we say, okay, what is that equivalent to? How could I write that the simplest way? And that would be cosecant to the 4th x. Okay. Now in this next problem, it wants us to factor before we simplify. So let's find a common factor. We can see that tangent x is common between those two terms. So let's go ahead and factor it out. This would be tangent x. When I factor it out, remember it's like I'm dividing tangent, dividing by tangent on each term. So here I'd be left with sine squared x inside the parentheses, and over here I'd be left with cosine squared x inside the parentheses. Okay. And hey, look, that's a Pythagorean identity. So that's one of our identities, that sine squared x plus cosine squared x is equivalent to 1. So I can replace that whole thing with just 1. So I have tangent x times 1. That's just going to be tangent x. Okay. The next one's very similar. We want to look for what both terms have in common. So think about the fact that sine to the 4th is really made up of sine squared x times sine squared x. So we can see that both of these terms have sine squared x in common. So we can factor it out. Sine squared x times, okay, what's left that goes inside the parenthesis? Well, think about it like you're dividing each term by that sine squared x and see what you'd be left with. So if we divide the first term by sine squared x, I'd be left with 1 sine squared x. Then we have plus, we divide the second term by sine squared x, I'm left with cosine squared x. And again, we see that Pythagorean identity. Sine squared x plus cosine squared x, that equals 1. So I multiply that, and I'm just left with sine squared x. Okay. For example number 3, again, we're just going to cancel out what we can. Keep in mind that this cosine squared x, really that's just cosine x times cosine x, right? And that's multiplied by that sine x. And in the denominator, keep in mind that what this sine squared x really is sine x times sine x. Then we have the cosine x. Now what all can we divide out? Well, this cosine would divide by that cosine, and one of the sines would divide out, right? Sine x divided by sine x is 1. So I'd be left with cosine x over sine x. And we don't like to end with fractions if possible, so I try to use up one of my identities to simplify that even more. And cosine x over sine x, we can simplify that by just writing cotangent x. Number 4 is a little bit harder because we're going to have to try to factor up top. What I like you to think about is almost like a u substitution problem. So if I look at this term right here, let's call sine x u for now. And we'll look at almost just factoring the numerator. So if sine x is u, then u squared would be sine squared x. So let's just replace that up top. I would have u squared plus 2u plus 1 over, this would be u plus 1. And if I factor that, what would that numerator factor to? Well, it would be u plus 1 times u plus 1 over u plus 1, right? What would cancel? Well, we could see that those would divide out and just become 1, right? Anything divided by itself is just 1. So I would just be left with u plus 1. And what did we say u was? U was sine of x, sine x, right? So I'm going to replace that u again with the sine x and be left with sine x plus 1. Same kind of idea here. There's not really anything that we can't simplify this anymore because it's already written in terms of sine and cosine. But with that addition and subtraction, I can't cancel anything out right now. So our only option is to try to factor this. So again, let's call u, in this case, sine theta. Then u squared would be sine squared theta. If I replace those signs with the u or u squared, I would have u squared minus 1 over u plus 1. Okay. In the numerator here, we see difference of two squares. Keep in mind difference of two squares. If we have a squared minus b squared, that equals a plus b, a minus b. Okay. So I'm going to think of my a squared like it's u squared, and I'm going to think of my b squared as being 1. So if I square root each of these terms, a will be equivalent to u, and b would be equivalent to 1. So I would write u plus 1, u minus 1 over u plus 1. We can see that these would cancel, right? If we divide u plus 1 by u plus 1, we just get 1. So I'm really just left with u minus 1, which what was u? U was sine theta. So I will have sine theta minus 1. And there you go. Hope that helped everyone.